welcome to Lecture 10, 1.4, Quadratic Equations. Alright, so we're moving up. Instead of linear equations, we are in quadratic equations. So a quadratic equation is in the form of ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and a does not equal 0. Why can't a equal 0? Well, if a equaled 0, this term would be gone, and we'd be left with a normal linear equation. So the main thing to note here is that we are no longer in linear equations. How can you recognize a quadratic equation? Well, a quadratic equation is when you see the highest power of any of your terms is a 2. Then you are in quadratic equation land. So the plan for solving changes. Let's take a look at some of the plans for solving. So the plan often changes based on what your quadratic equation looks like. So one of the first plans we have is solving quadratic equations using the zero product property, or often called the zero factor property, which is what I normally call it. So the zero factor property is if you have two numbers multiplied together and their product is 0, then you know that either the first number is 0 or the second number is 0. So with that concept, let's go ahead and take a look. Well, what we want to do is create a multiplication problem on one side. So taking a look at a, at the moment, it's not a multiplication problem. We have subtraction. How could we make this look like multiplication? Well, the answer is in the name of the property. Zero product property. Or another, zero factor property. So our plan, we're going to factor. Okay, so let's factor that side. Taking out the GCF first, we have x times x minus 8, and that's all we can do. So now we have a multiplication problem. We have x times x minus 8, and it equals 0. Well, what do we know about the property we were given before? If you see two numbers multiplied together and they equal 0, then either the first number equals 0 or the second number equals 0. Let's go ahead and do that. We know that either x equals 0 or x minus 8 equals 0. Okay, so one thing to note. You need to write out each product or each factor equal to 0. Some students get into the habit of skipping this step, but this step is really important. A lot of professors, especially in some of the higher courses, will look for it, and this is a step that I'll be looking for as well. One thing that would be good is to take a look at how I write out my work, because oftentimes that is how I grade you. If sometimes your work on a quiz jumps a step that to me seems too large to have done in your head, you might lose points on it, okay? So make sure if you do use scratch work, show it on the side so that I know where you get your answer from. All right, so, well, we already solved here, x is equal to 0, so that's done. Solving the other side, add 8 to both sides of the equation, and we get x equals 8. So we have two answers. All right, let's take a look at the next one here. Well, for the zero factor property, one of the main things that we need is we need it equal to 0 in order to use the property. And at the moment, it's not equal to 0. It's equal to negative 40. So let's move that 40 over. Then we have 10 times 3x minus 13x plus 40 equals 0. Well, I want to make this side look like a multiplication problem. In order to do that, I need to distribute out the 10 and then see if I can factor. So we have we have 30x minus 130x plus 40 equals 0. Combining the like terms of the 30x and the 130x, we have negative 100x plus 40 equals 0. Let's see. Let's rewrite this a teeny bit. 40 minus 100x equals 0. Now, let's see. Can we factor this in order to get it set up to be in the zero factor property mode? Yeah, we can take out, let's see. If we take out 10, then we would have 4 and 10 left. But each of these still can get a 2 out of it. So let's take out 20. Factoring out 20, we're left with 2 minus, and then 100 divided by 20 is going to be 5. All right, so as our zero factor property states, if you have one quantity being multiplied to another quantity and it equals 0, then it must be that one of those equals 0. And notice this statement here, that is false, so we can just go ahead and say that's extraneous, cross it out. Let's go ahead and solve the other side here. Minusing 2 from both sides. Negative 5x equals negative 2, running out of some space here. Then x equals 2 divided by 5, and that is our answer. All right, so as usual, the plan is to create a multiplication problem on one side and make sure it's equal to 0. That was a problem in the beginning here, was that it wasn't equal to 0, so we had to add the 40 to both sides. Now let's take a look at another way to solve quadratic equations. So once again, these are different methods. And the method, sometimes one method is better than the other, and it often depends on what your equation looks like. So now let's take a look at objective 2, which is solving quadratic equations using the square root property. To me, this property is often the easiest one to use. The problem with it is it's often hard to find a problem that looks the right way to use this property. What do I mean? Well, for the square root property, you need to have your variable squared equal to a number. So a normal quadratic equation, like the ones we had up here, this one would not work. Why not? Because we have that 8x. We have power 1. So this one would not be a good candidate for the square root property. All right. So for the property is if it's in this special form, then what you can do is you can take the square root of both sides. But when you do that, very, very important, please pay attention, you need to use the plus or minus. Why? Well, let's take a look at an example. Why plus or minus? Okay, so if you had a number, let's say x squared equals 4. What are the possible answers for x? What number times itself could give you 4? Well, you might say 2, right? 2 times 2 is 4. But I'm going to argue with you, there's one other answer. That answer is negative 2. So if you tried to use the square root property and you took the square root of both sides and you just said that x equals the square root of 4, which is 2, you would have left out one of the solutions, which is negative 2. We shouldn't be leaving out solutions, right? We want to know all the possible answers for math. So because of that, you need to be very, very, very careful. Please note this. You need to add that plus or minus. Because there are two possible answers, the positive version and the negative version. Once again, this is something important I will be looking for on your exam. If the plus or minus is missing, then that will be some points deducted, because that means you'll be missing half of your answer. Okay, so enough of the side blip. Let's get solving. Well, the first one. Well, you know what? That is set up just perfectly. We have the x squared equal to the number. It's beautiful. All right, let's just go ahead and square both sides. Everything is set up wonderfully. So, square root. I forgot the plus or minus. Please put that in. Check your work, make sure you wrote it. Okay, so when we do that, the square cancels with the square. And we're left with x equals plus or minus the square root of 81. We can simplify that and we get x equals plus or minus 9. And we can box that answer. Now for B, let's see. Well, it's not really in the perfect form. We don't have our y squared by itself. And one thing to note on this problem, there is a small typo, which hopefully I've fixed on your paper that you have now, but that should be a minus 36. All right, let's go ahead and solve. So we want to get that y squared by itself. Let's add 36 to both sides. And we have 2y squared equals 36. Now, still getting y squared by itself, dividing both sides by 2. Then we have y squared equals 36 divided by 2. And 36 divided by 2 is 18. Okay, now it is in the perfect form for the square root property. We have our value squared equal to a number. Awesome. All right, let's go ahead and use the square root property. Oh, I need to remember that plus or minus sign. Okay, then these guys cancel. And we're left with y equals plus or minus root 18. Can we simplify root 18? Well, there's a 9 in there, so we can take out that perfect square root. And there we go, with our answer, 3 root 2. Now let's take a look at the last one. This one's a little suspicious. We have parentheses squared with our variable. But our variable doesn't appear anywhere else. It's only inside the parentheses squared. So once you see that, you know you can use the square root property, which it's sort of mentioned right up there. So if your variable only appears inside what's being squared, then you can do this. If it's outside somewhere, like hanging out there, then you can't do this. All right, well, let's just treat this as the object being squared, so let's get it by itself. Let's add the 24 to both sides. Then we have t plus 4 squared equals 24. And let's take the square root of both sides. Remembering that plus or minus, very important. Can't forget an answer. Canceling out there, t plus 4 equals plus or minus the square root of 24. Let's see, can we simplify the square root of 24? There is a 4 in there. Yep, so we can simplify that. Plus or minus 2 root 6. Now let's still solve for t. Get rid of that 4 by the t. Now notice, I'm going to do something interesting. Whenever you have that plus or minus symbol, anything you add or subtract should go up in front of the plus or minus. Why? It's just less confusing. Okay, so t equals negative 4 plus or minus 2 root 6. We can't actually do the addition or subtraction because we have that radical, so we'll leave it as it is and box our answer. So one thing to notice, the way I write my t's is I add that little tail there, just so I don't get it confused with the plus sign. All right, so that was the other special method, square root property. Now let's take a look at one other method. This is called completing the square. And basically what it does is you're going to create a perfect square trinomial. So some value squared. And then use the square root property to solve. Okay, so the goal is to get it into the perfect form, which we saw on the last one here. And then solve. And oftentimes, you're missing a number to make the perfect square trinomial. So the first thing you want to do with a perfect square trinomial, or to get a perfect square trinomial, is you want to get the number on one side and all the ones with the variables on the other. So that's the first step. Let's go ahead and do that. We've got the x squared plus 10x equals negative or positive 3. Now, we want to create a perfect square trinomial, which means we want to figure out a number to add to this side that will make it factor perfectly into two binomials that look the same. Let me give you an example of a perfect square trinomial. X squared plus 4x plus 4. What does this factor into? This factors into x plus 2, x plus 2, which I can rewrite this into x plus 2 squared. Why is this important? Well, remember when we were solving this problem up here, it was important to have it in that squared term, the binomial squared. So we're being a little manipulative here with problems. Mathematicians can be a little manipulative. Our goal is to be able to create a trinomial that when we factor it, the two terms are identical. Then we can write it as something squared and then use the square root property. Sounds pretty easy, huh? The only problem is finding out which number works. What number should I add to this side to get a perfect square trinomial? Well, you could sit down and guess and check every single number there is, but a mathematician figured out how to do this. What you're going to do, first, take the value by the x. Then you're going to divide that value by 2. And lastly, you're going to square it. So 2 steps. So what is 10 divided by 2? That's 5. And then you're going to square that, and that equals 25. What's important about that number? This number is the magic little guy that'll make my trinomial factor perfectly into identical binomials. Okay? This is the number, the star, the wonderful one, the chosen number. Okay. So, what should I do with that number? We're going to add it into our equation. Let me rewrite our equation. So I want to go ahead and add the 25 into our equation. But there's a glitch. When I add 25 to this side, I have just unbalanced our equation. How do I balance the equation? Well, I'll just add 25 to the other side. Then I balance the equation. I haven't done anything wrong. We know if you add something to one side, it's okay as long as you add something to the other side, right? Okay. So, let's check. Is this number really the chosen number for our problem? Let's try factor this. Well, this will factor into x plus 5 times x plus 5. What do you know? Are these two guys identical? They are. So then I can write them in that x plus 5 squared form that I really wanted to write them in. Because then I can use the square root property. We've done it. So that adds up to be 28 on the other side. And now look at this. Isn't this beautiful? That is in the perfect form to use the square root property. All of that hard work has paid off. So let's go ahead and square root both sides. Remembering that plus or minus. And then we get x plus 5 equals plus or minus root 28. Sorry, that canceled. Can we simplify root 28? There is a 4 in 28, so we can take that out. And in the same step, I'm going to go ahead and subtract the 5 from both sides. Remember to put it in front of the plus or minus. Then we get x equals negative 5 plus or minus 2 root 7. So I simplified the 28 and moved the 5 over in one step. And there we go. Our answer. Okay, so the big thing about all of this is we want to get it to this step right here to be set up perfectly for the square root property. And to do that, you need to find your chosen number. So you use that little fancy trick right here, where you take your b value, divide by 2, and square. Okay? Fancy trick. All right, so go ahead, try pause the video and see if you can complete the square on this problem. Check in with me in a second. All right, so let's take a look at this. First off, there is actually a hint that you do not know. What we need to make sure is before we complete the square, the x squared should only have a 1 in front of it. So sorry if you've done a lot of work. But you'll know it doesn't work if you don't have the x squared in front of it. So we got to get rid of that negative 3. We just need a positive 1. Very important, please remember this whenever you try to complete the square. If not, things will go pretty badly. Alright, once we've done that, let's go ahead and get the number to the other side so we can start our completing the square process. Let's see. Then we have x squared minus 5 over 3x equals negative 7 over 3. Now, once again, we need to find that perfect number. And how do we find the perfect number? Well, take your b value, divide it by 2, and then square it. All right, let's see. Negative 5 divided by 3 divided by 2 is going to end up being negative 5 over 3 divided by 2 squared, which is negative 5 divided by 3 times 1 over 2 squared, and negative 5 over 3 times 1 over 6. This is all scratch work. You don't need to include this on the main part, which is negative 5 over 6 squared. Negative 5 over 6 squared is going to be 25 over 36. That right there, my friends, is the perfect number. Okay, so let me write that down on the side. You wouldn't have to do all this workout. If you could do this part in your head, that would be perfectly fine. Okay, 25 over 36. That's our perfect number. Let's go ahead and add that into both sides. Plus 25 over 36 plus 25 over 36. Then we have x squared minus 5 over 3x plus 25 over 36. Okay, how do we add these two? We got to create a common denominator for these two fractions. 3 can go into 36. I need to multiply it by 12. Oops, got a different color here. And then 12 times 7 is 84. Alright, so next step, I'm going to go ahead and factor this side. This will end up being x minus 5 over 6 times x minus 5 over 6 equals, and then 84 minus 25. That'll give us, negative 84 plus 25. Going to be 59. Okay. Then we have the x minus 5 over 6 squared equals negative 59 over 36. We're running out of space here. Let's take a square root of both sides. Oh, do you see what happened there? We have a negative inside the radical, and our instructions include complex numbers if there are. So we're going to take that I out, because that's the imaginary number I. So then we get x minus 5, 6 equals plus or minus I. Oops, the I comes after. Root 59. I'll simplify the 36 here over 6i. Then let's go ahead and add the 5 over 6 to both sides. Really running out of room. X equals 5 over 6 plus or minus the square root. 59 over 6i. There we go. That is the answer for that problem. Always please remember the plus or minus. And now, one thing to note. If there was a negative under the radical and your instructions did not say to answer over complex numbers, you could go ahead and ask me, or you could say at this step, assuming complex numbers, and you could keep solving. All right, objective 4, solve quadratic equations by using the quadratic formula. All right, so there's a song for this, and I'll go ahead and post that video to YouTube. Oh, not to YouTube, sorry. To Leveling Before You. It's from YouTube. So we have the definition for an equation in the form, which we've seen before. The solutions are given by the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So the basic plan for this, get your equation into this form. So it's a different form than the other ones we've been working with. And then from there, the value next to the x squared is your a. The value next to your x to the first power is b. And the value without a variable is c. Let's take a look at our first problem. Gosh, it's not even in the right form yet. It's not equal to 0. And we have these weird parentheses. So let's go ahead and get this in the right form. Okay, so distributing that, we get x squared minus 8x equals 3 almost in the right form. We got to get that 3 to the other side. And then we have x squared minus 8x minus 3 equals 0. All right, now it is in the perfect form for using the quadratic formula. So let's find a, b, and c. I always like to state them on the side in case I drop a negative or something. So a, it's the value by the x squared. But what's by the x squared? It's just 1. Whenever you don't see a number, that is the 1. All right, b is negative 8. Please remember the negative. And c is negative 3. All right, let's go ahead and stick these in. Be careful. Generically, we have x equals, but sometimes in your problem, you won't be solving for x. You might be solving for another variable. So please make sure to write the right variable down. X equals negative b. The opposite, what is b? B is negative 8. Okay, then we're doing the plus or minus. So plus or minus the square root of the b squared. What is b squared? Negative 8 squared minus 4 times AC. AC. Okay, I need to extend my radical here a little bit. Don't want to have our radical too short. All right, and then our A value is 1. And our B value, or our C value, sorry, is negative 3. And then 2 times A. And our A value was 1. All right, so we plugged everything in correctly. Let's go ahead and simplify. You could pause the video and try to simplify this on your own. X equals 8 plus or minus the square root of 64 plus 12 divided by 2. X equals 8 plus or minus the square root of, that's going to be 76 divided by 2. All right, can we simplify the radical? Well, inside that radical is 4 times 19. So this is going to be 2 root 19 all over 2. Now let's see, can we factor from anything from the top? Okay, so real quick, please do not do this. We can't just cancel the 2 and the 2. Why not? In order to cancel, we need multiplication. There's still this addition. That addition is blocking the 2 from being canceled. So we need to factor out the 2 first from the top. Then we get the 4 plus or minus root 19. And once we've done that, then now we can cancel the 2's. Why? Because we have that multiplication. Please remember that. You do not want to be knocking off points for a student canceling the wrong number. All right, and then x equals 4 plus or minus root 19. And there we go. We have our answer. Let's take a look at the next problem. All right. Well, it's kind of set up in the right form. We have our x squared, or x, and our c value, and it's equal to 0. But you know what I don't like about it? Are those fractions. I really don't. Can I get rid of the fractions? I can. It's an equation. So if I multiply one side of the equation by one number to cancel the fractions, I just multiply the other side by 0. So what's the common denominator here? The lowest common denominator is 12. So remember, my plan is to get rid of the fractions. I'll multiply both sides by 12. The 12 will get multiplied in to each of the factors. And let's see what's left. That's going to be 5x squared minus 6x plus 3 equals 0. And look at that. The fractions are gone. Awesome. Now let's identify a, b, and c. Okay, so why did I cancel the fractions? Well, can you imagine plugging in fractions into that quadratic formula? That would look pretty hideous, plugging fractions into there. So if you can get rid of them, that'd be a good plan. Well, a is 5, b is negative 6, and c is 3. The variable is x, so we can go ahead and write x equals negative b plus or minus square root of b squared minus 4ac all over 2 times a. I'm going to go ahead and extend that radical bit. So we have 5 times c all over 2a. Okay, go ahead and try to simplify this by yourself and check back in with me. X equals 6 plus or minus the square root of 36. 4 times 5 is 20. 20 times 3 is 30. Ooh, 60. All right, so at this next step, we're going to run into a little conundrum. We have a negative 24 over 10. That negative implies that we have an imaginary number. So the question is, were we told to solve over complex numbers? And it did not tell us to solve over complex numbers. So if you were not told to solve over complex numbers, what you would say is no real solution. Why? Because that's an imaginary number. So this is if not told to solve over complex numbers. However, if you were told to solve over complex numbers, I'll go ahead and show you that. So actually, technically, because this problem did not tell you to solve over complex, that would be the answer. But let's say they did. Let's go ahead and take a look at that. Well, we'll change that negative to I. So we get the square root of 24i all over 10. Continuing over here, simplifying the radical, we get 2 root 6i over 10. Now let's split that fraction, because remember, for complex numbers, you need to answer in a plus bi form. And then we can simplify here. And we're left with x equals 3 over 5 plus or minus 2 root 6 over 5i. So if you'd been told to solve over complex, you would have answered with this. If you hadn't been told to solve under complex, you would say no real solution. Once again, it does depend on your instructions or the directions. Okay, so for 5, talking about the discriminant, that's just talking about if you get a negative under the radical or if you get a 0 under the radical. We don't cover that in 103. If you're interested, go ahead and read your book for that. Or you can ask me in an email. The last objective for this section is solving an equation for a specified variable. So for A, we want to solve this equation for v. Now notice v is being squared, so we should be thinking quadratic. What I'm going to do, because I just see my variable squared and I don't see it anywhere else, I'm going to use the square root property, which means I need to get the half m to the other side. So let's rewrite this equation. Multiplying both sides by 2, so we can cancel out that 2 in the denominator. And then we have 2e equals mv squared. Once again, our goal is to get the v by itself. Let's divide m from both sides. And then we're left with v squared equals 2e over m. Notice I switched sides for the equations. That is perfectly fine. They're both still equal to each other. Lastly, let's go ahead and use the square root property, remembering that plus or minus, once again very important. That cancels, and we're left with v equals plus or minus root 2e over m. And we are done. We can't simplify those values, so we're just going to leave them as they are. All right, last one. Let's see. We're told to solve this for p. So let's take a look at our equation. Where's p? We have a p squared and then a p. How would I solve that? I can't use the square root property because I have that p to the 1 power going on, so no square root property. I can't use zero factor property. Let's write this down. What are the tools we have for quadratics? Before we go any further, we have square root property. We have zero factor. We have completing the square. And we have quadratic formula. These are the 4 methods we now know for solving quadratics. Which one will work? That's the question. Well, I already said square root would not work because we have that p to the 1 power. Zero factor property wouldn't work because I don't know how to factor this. There are no numbers. That wouldn't work. And then completing the square would also not work because, well, I mean, actually, we could try completing the square. But it might be a little difficult, so I'm going to try hold off on that. Could I use the quadratic formula? I could. Let's go ahead and try the quadratic formula. So to do that, we need to get this equal to 0. And my a, b, and c values, let's go ahead and list them out. So c is my a. B is negative d. This is kind of weird because all the variables are flying around. And c is negative k. All right, I got to keep this straight. So what are we solving for, x or p? We're solving for p, so careful. When you set up the quadratic formula, you need to say p equals. So we want opposite of b, which was actually, careful, negative d. It's getting a little confusing. Plus or minus the square root of b squared minus 4ac all over 2a. So let's plug those in. B squared, so that'd be negative d. A is c. C is negative k. Oh, this is interesting. And a is c. Let's see what we can simplify. P equals d plus or minus the square root of d squared plus 4ck. Negative times a negative gave me that positive. And the negative d squared gives me the positive d squared. Divided by 2c. Now you might be tempted to try and simplify further, but there's really not much more we can do. Because these are not all numbers, you can't do that much more simplifying. So actually, we are done. Let me redo that so I can actually see the p. And there we go. That was not good. One more try. Give me one more try. There we go. All right, that was it. If you run into any problems for solving, please go ahead, send me an email. I'll do my best to get back to you as soon as possible.